Yes, can you hear me, Alex?
Yes, all right.
Okay, good. This present work has to do with the quality of works, compliance with existing legislation, and reliability of EPC data in Greece. The scope of this Greek new building study collection is the collection of data for 26 residential and non-residential buildings which are newly built and renovated, most of them according to the National Framework Energy Efficiency at Household Buildings. And I would like to say a few words about this project in order to have a more clear aspect about the procedure that is followed. The Ministry of the Environment, Energy and Climate Change of Greece, having completed the legal framework on the energy efficiency of buildings, has developed a set of financial incentives with co-funding from the European Union for the implementation of energy efficiency upgrading intervention in residential buildings via this program that I said before. So the eligible interventions of this program were related to the installation of thermal insulation at the building envelope, frames replacement and installation of shading systems, and upgrading of the heating system and domestic hot water systems. So in order to join this program, energy audits are required before as well as after the intervention, and the cost of which is covered by 100% from the program. And in any case, after the successful implementation of this project. This means that initially the energy auditor examines the building and the existing case of the building and issues a first certificate for the existing condition, and then proposes appropriate interventions in order to improve the energy efficiency. And once these interventions are completed, the energy auditor must examine again the building, certify that the proposed interventions were implemented, and issue a new EPC in which this building must necessarily have risen at least one energy class, or its energy consumption is reduced about 30%. So these buildings that we collected were well-documented buildings with focus area on the quality of works, compliance with reference values, and the reliability of EPC input data, and the location was all over Greece. The aim of this study is to examine in these buildings the quality of works through on-site inspections and measurements, the compliance with the reference values from the national technical guides, and the reliability of EPC input data. The methodology that we followed in order to perform this work can be divided, can be followed in as this structure here presents. So the quality of works through on-site inspections and measurements included air tightness tests, infrared thermography of the building envelope, site visits and inspections to check actual construction. The other aspect has to do with the compliance with the reference values from the national technical guides. That includes the ventilation measurements and measurements of temperature and relative humidity of indoor spaces. And the checking of the reliability of EPC input data by comparing the U values of the design with the actual U values of the materials used in the construction as reported in the final EPC. When we say design values, we refer to the values as they were proposed, as I said before, at the first audit by the auditor before the interventions. Then comparing the design values of technical characteristics of the solar collectors with the technical characteristics used in the construction as reported in the final EPC. And finally, checking the accuracy of EPC calculations. The selected case studies and methods. Here we can see briefly the number of the case studies, and in the following slide there are the rest of it, 26 in total. We can see here the type of interventions, the type of quality and compliance control. So Regarding the type of interventions, we have frames, insulation, and solar panels. And regarding the type of quality and compliance control, measurements, on-site visits, invoices and certificates of materials checking, and EPC calculations checks. And here we can see for each building which type of control was implemented. So starting from the quality of works, we performed measurements regarding the tightness levels, and here we can see in this table the tightness levels from low, medium to high based on N13790. Here in this table we can see that for the majority of the buildings, for 68% of the buildings that were examined, the tightness levels are lower, the air changes per hour values are lower than 4, which means that we have a high envelope tightness level that shows a good tightness quality of the buildings. Concerning the quality of works, we also had thermographic inspections and on-site visits. Concerning thermographic inspections, we carried out this type of testing in 7 buildings that external thermal insulation was implemented in order to detect the defects in the insulation. The inspections showed that the external insulation of the building's envelope was well implemented without any gaps or between the insulation boards, and this is an indication of good quality of works in these buildings. On-site visits simultaneously took place in 19 buildings, and the quality of works was investigated. So more specifically, the implementation of the window frames and the external insulation was checked, and this inspection showed that the frames installation was of good quality and with no gaps between the frames and the walls that were detected. The checking of implementation of the thermal insulation confirms the finding of thermal mapping too, and these findings are due to the fact that that having no specific problems is due to the fact that the vast majority of these case buildings are buildings that were renovated under the program that I explained before, the energy efficiency at household buildings, which is a program that has strict quality assurance measures. Concerning the compliance with the reference values, we performed measurements for ventilation, and we compared the results with the airflow, the reference value according to the technical chambers of Greece and the related directive. We compared the findings with this reference value, and according to this figure, 10 case studies have ventilation rates higher than the indicated value, and in 6 case studies the measured ventilation rate is lower than the reference value. In 4 case studies, the ventilation rate is almost equal to the reference, and we could say that although there are some differences, the variation could be considered, except of a couple or 3 cases, could be considered rather small. It could be concluded from these results that there is quite moderate to good compliance with the reference values. We could move on to the compliance with the reference values concerning the temperature distributions. The findings were compared against the reference values from the national directive of the technical chamber, which is for summer conditions 26 degrees for indoor temperature, and in the next slide we will see the related reference value for the relative humidity, which is about 45%. Here we can see that in this diagram we can see the mean daily temperature distribution, just indicative for one case study. These are the diagram is averaged for the whole time period that the measurements took place. So here we can see an indicative diagram for this case study for the temperature, and this is for relative humidity. And here is the total air temperature for all the case buildings that we performed the measurements. In this diagram, we can see the mean daily, the mean maximum daily, and the mean minimum daily temperature for all our case studies. So as it could be concluded from the diagram concerning the indoor temperatures, just a clarification, when we refer to total area temperature, there were metering systems for the temperature and the relative humidity placed in different spots inside the apartment. It could be in the living room, in the bedroom, or in the kitchen. So when we say the total area temperature, these are the values that are averaged for the whole area. Here we can see that, as it is illustrated, in the most of the cases, the mean values are higher than the reference values. And this could happen for a number of reasons. The majority of the case studies are the buildings that are renovated under the program that we mentioned before, which imposes the improvement of their energy efficiency by one category class after the intervention. So one common way to achieve this target was the installation of solar collectors, which, however, does not necessarily improve the thermal comfort of the building. So during summer and in winter conditions, the buildings have internal temperatures that exceed, in some cases, the reference values. It is worth noticing that, for example, in the case study number 13, that we can see the highest values, this is an apartment that the interventions did not include the installation of external insulation. Moreover, we could say that the tenants, the inhabitants of the buildings, use the cooling system only in exceptional cases when heat waves occur. Now, concerning the relative humidity, we can see variations between the different case studies. During the summer, most of the tenants used to keep the windows open, so indoor relative humidity is influenced by external conditions. And we could say that the measurements, in some cases, they took place at different time intervals. So maybe another reason that we observe these differences is the use of appliances as cooking appliances that in many cases increase the relative humidity of indoor space. And the tenants, usually they have also different habits that influence relative humidity. Now, concerning the other aspect of our work, it has to do with the reliability with EPC input data. Here, what we did is compare the material implementation values as reported in the invoices and the certificates of the materials used in the final EPC, which means the EPC after the implementation of the interventions, with the design values as they were proposed in the first EPC. So here we see for the number of buildings that we did this check, that with respect to the window frames, it was found that in 8 buildings, the U values of the frames were identical, which is a percentage about 22%. In 6 buildings, which means that at 33%, the U values of those installed was lower than the design values, and 17%, only one building implemented higher values than the design ones. So Another aspect that we could mention is the high percentage of buildings that neither the auditor nor the contractor had the certificates in their archive, which is considered to be an aspect that needs consideration. So we could not perform these controls in the buildings. Of course, we had another control about the range of the difference. We tried to investigate the range of the difference between the design and the implementation values is also reported, and here we can see that by 0.6 to 35%, the frame's U values are lower than the design, and about 25% the implementation values were higher than the design values. This work was done also for the external insulation and the solar collector area. So, concerning the external insulation in 3 buildings, in a percentage of 19%, the U values were found to be identical. For about 25%, the construction U values are higher than the design U values, while there are also 4 buildings with U values lower than the design. Here we also have an important percentage that no invoices or certificates could be found. So here in this table we can see also the range of the difference for the external insulation and the comparison of the materials implementation and design values for the solar collectors. The percentage that is identical, that these values are identical, is by 16%. Concerning the reliability with the EPC input data, in order to investigate the accuracy of EPC calculations, the following documentation were collected: drawings, construction characteristics of the buildings, and corresponding technical reports. The files of the EPC calculations, these are the input files, and they incorporate all required data for the execution of the calculations with the software that it is approved by the Technical Chamber of Greece. The certificates and invoices of the materials used in the construction in its case study, and the energy performance certificates before and after the renovation, which includes the energy performance classification of the buildings. So the validity of the calculations in the EPCs was examined, and the input values were also checked and compared with the proposed values by the national building codes. This control was made by cross-checking the values that are inserted in the corresponding EPC input file for each case study with the implementation values. And when a mistake was found, it was replaced by the right value, and after this there was a cross-checking and recalculation with the EPC software, which was executed again in order to assess the building's energy class. The procedure demonstrates that in most of the cases, faults were not involved, and this can be attributed to the strict controls and sanctions of this program. However, in one EPC, errors were found that were affecting the energy classification of the building, making it an actual G instead of F, as it was declared. So, in order to conclude, I would like to mention some challenges and lessons learned from this work that it was performed. We had some difficulties finding a number of completed case studies with EPCs before and after the renovation, which number was rather small. That's why we found some difficulties in finding this amount of buildings. Data was not always easily accessible, and the person in charge, sometimes they were reluctant or negative in providing such information. Even if the data was accessible, there were some difficulties sometimes from the owners to provide the permission, and a main aspect was the inhomogeneity of accessible data. That means that, as you saw from the presentation, it was not easy to find just one parameter and make a full report in this parameter, because this could not be reported or investigated, this parameter, in every building. We did not have enough data to perform the check of one parameter in all the buildings. So that's why we did, let's say, a more holistic work on this. Despite the challenges, I think that we adequately addressed them, and I think that we conducted successfully this study, and we found some interesting results. Concerning the lessons learned, there are, of course, other type of buildings, such as commercial buildings, that are constantly air-conditioned, and they would also give some interesting results regarding the internal temperature and relative humidity. And in buildings that are under construction, it is, of course, easier to check some issues concerning the insulation and the validity of the data and the right installation of window frames. But in the present study, it was not very easy to find them. They were not available. So I think this is all from my point of view and from this study. Thank you very much for your attention.